So did you get the parts for this triangle? You should have gotten angle C is 53.464 degrees. Angle A is 86.536 degrees. And then side C, 6.212 degrees. Okay, now we're going to check to see if there is a second, and we know that there is because it says so, but this is how we're going to check. So we come down here, let me close this window here, and we're going to check for second triangle. And we're going to look for triangle A, B, C prime. So we're going to first swing the side. So this is the side we're going to swing. So we're going to move it over here, and I'm just going to draw another one. It kind of looks not perpendicular great, but it's just, it's not, needs to be perpendicular. So there, it looks kind of like this. So we declare that it is congruent to that, and we've just moved it, just shifted it up here. Okay. We know that this is approximately 53.5 degrees right here. And so that means this angle also will be approximately 53.5 degrees because of the isosceles triangle. So the first step is we're going to swing, just so that you have some notes, swing side AC prime to form triangle ABC prime. So that this, here's A, B, C prime right here. I'll circle it so that in color so that you can see it. C prime. And then we know that angle BCA, angle C, is 53.464 degrees, and so angle C prime is also that. So we're already solving triangles. So this is that, but right here, this is angle C prime A. Okay. And so now angle C is actually this one right here, C prime. So we're going to find that by subtracting. We'll find angle BCA. Will be 180 minus this. Okay. And we calculate that to be 126 degrees. So that's a pretty large, obtuse angle. And we check it to see if we can actually get a triangle with these angles. So angle at B plus angle C prime are equal to 40 degrees right here. See the 40-degree angle plus 126 degrees. So that's equal to 166 degrees, 0.536 degrees. And that is less than 180 degrees. So check, we could make another triangle. So there is a second possible triangle. And we'll find it. So we know that angle C prime is 126.536 degrees. Angle A will equal 180 minus that, and minus the 40 degrees that we're given. And so that'll be 13.464 degrees. That's angle A. Okay, now we still need to find side A prime. Little A prime is, you know, this little thing right up here. I'll do it in pink so that you can see it. This little right here. So side A prime, little A prime side is, we'll find it by using the law of sines again. So the sine of sine of 40 degrees divided by 4 is going to equal the sine of this angle, 13.464 degrees. If you've still got that stored in your calculator, great, and you use that. A prime. So A prime will equal, cross multiply and get that algorithm to type into your calculator. And here it is, 13.464 degrees divided by the sine of 40 degrees. And so that's equal to 1.449. So there you go. The second triangle, we've solved it. All right, let's do one that has no triangle so that you can see what happens. Then we're going to draw information's given as side A is 2, C is 1, then the angle, we'll call that angle C, is 100 degrees. So I'll just draw the triangle. It's not at all what it really looks like because it's not going to make a triangle. So this is side B. Side C is 1, side A is 2, and angle C is 100 degrees, which is an obtuse angle, and I've not drawn it that way. So we're going to find angle A. Okay, so the sine of 100 degrees over 1, so 1, is equal to the sine of A, whatever that is, divided by 2. And so we'll calculate the sine of A is going to cross multiply 2 times the sine of 100 degrees. And so we want to use the inverse sine there. Get the calculator. So we want the angle that has that as the sine. So second sine, make sure your degrees. 2 times the sine of 100 degrees. That's what we want. And we get a domain error. That tells us right there that it's not possible. And so we know that there is no triangle with those dimensions. Okay, let's do some applications on the back. We've got a plane, airplane takes off. A takes off from the carrier. B, here's the plane, takes off from the B. It flies in a straight line for 12 kilometers. At that instant, an observer on destroyer C, right here, located 5 centimeters from the carrier, notes that the angle determined by the carrier and the plane is 37 degrees, so this angle. How far is the plane from the destroyer? So basically we want to find B. So we'll make a note for that. So we need to find B. But we don't know angle B. So we have to use angle A to calculate. So we're going to use the law of sines. We're given side, angle. And so it's sine of 37 degrees over 12 is equal to the sine of angle A over 5. And so we want to find, we'll go ahead and calculate the algorithm. So we take 5 times the sine of angle A will equal 5 times the sine of 37 degrees divided by 12. And we'll put that in the calculator. So go ahead and do that. And you'll get A equal to 14.522 degrees. You should. So angle B is going to equal 180 minus that and minus 37. You might ask, well, what if it's the ambiguous case? But you know what? We're given this information, so it's not ambiguous. There's a triangle here. This is the triangle that they want to use. They've given the picture for it. So angle B is equal to 128 degrees 128.478 degrees. Okay, so we've got that. We've got A. So all we need now, we've got enough information to find side B. So we're going to use law of sine, which is this is what we want, side B. Sine of angle B divided by side B is going to equal the sine of 37 degrees divided by 12. And so building that algorithm, it's 12 times the sine of B over the sine of 37 degrees. And you should get 15.610 kilometers. Okay. Next problem is kind of interesting. It's a plane flying a straight line, goes directly over point A on the ground and later directly over point B, which is 3 miles from point A. So a few minutes later, after the plane passes over B, the angle of elevation from A to the plane is 43 degrees, so they've drawn it for you, and the angle of elevation from B is to the plane is 67. So how high is the plane at that moment? So we want H. So we want to find AC in order to, because that's the hypotenuse. Here's the triangle. Here's A. It's a right triangle, so we'd like to find the hypotenuse. It'd be pretty easy to do because this is the right triangle right there. We're given a bunch of other angle stuff that's going to help us find that because we could use the law of sines to do it. So we want to find side AC, which is the hypotenuse, the side. And we know that angle ABC is 180 minus 67 because of this. So right here is what we're talking about. 180 minus 67 degrees, which is 113 degrees. And so this angle BC is going to be, this angle up here is going to be 24 degrees. Up here. So this the third angle. So angle C, we'll call it. Little c is equal to 180 minus 113 degrees minus the 43 degrees that's right here. So this is 113. And so that'll be 24 degrees. And we'll just put it in right there, 24 degrees. Okay, now we want to find AC. So AC is we're going to find in this triangle. So we're finding an algorithm for it. Because then once we find the hypotenuse, we can find the leg, which is called the height of how high the plane is. So we'll take sine of 24 degrees. We've got that angle. Opposite over the hypotenuse. So the sine of 24 over 3 is equal to, using law of sines, sine of 113. Perfect. divided by this hypotenuse, which we'll call AC. And then AC is equal to, we'll cross multiply to get an algorithm to put in the calculator. So AC is equal to 3 times the sine of 113 degrees divided by the sine of 24 degrees. And you should go ahead and calculate, turn it off, and calculate that, 6.789. That's miles. Okay, now we want to find height using this large triangle. So here we're on the large right triangle. This is a simple sine problem, so simple trig problem. So we can do the sine of 43 degrees equals the opposite, which is h, over the hypotenuse, which is 6.789. And so h is equal to the sine of 43 degrees times the 6.789. Okay, and so h equals 4.630 miles. Done. Okay, you're ready to do homework.